What's up, everyone, and welcome. This episode is all about DevOps. What is DevOps? I'm going to break down and explain what it means from a machine and human perspective, how it is used, and how you can integrate it or improve it in your development workflow. Before I break it down, I want to give you the official definition. I use the Wikipedia definition because in my experience it encompasses the true essence of the term. There are a ton of sources out there that'll give you different definitions, whether it's the Gartner Group, whether it's Amazon's AWS or Atlassian, who develop Bitbucket and Jira. But most of them really just add a little bit of flavor to the definition by saying something like it's a culture or it's a philosophy or it's a movement. I believe what they really should be saying is it has become a standard. For those who are not familiar, I'm going to show you a typical infinity diagram here. In general, this diagram outlines the steps used in software development. So for all you newcomers, what do? You plan, you code, you build, you test, you deploy, you operate, you monitor, you release, you rinse, and you repeat. It is shown as an infinity diagram because you continue to follow these processes for all the features, updates, bugs, whatever. And you do that throughout the life cycle of the project. Now, you might be thinking, all these steps, that's a lot. Don't worry. I said I'll break it down for you, and that's exactly what I'm going to do. I want to go through both what I call the machine side and the human side. Most people are only focusing on the machine side. Automation, Jira, Circle CI, continuous integration. Everybody's screaming that. But I will note that one outlier out there is the Gartner Group. In their definition, they say, and I quote, DevOps emphasizes people and collaboration between different groups, mainly operations and development. So I'm not just going to do everything that everybody else does, but I am going to start with the machine side. So specifically, tools. You're not a tool. Congratulations. DevOps is intended to be a cross-functional mode of working. So those who practice the methodology use different sets of tools. So if you're a coder, you're interested in code development and review tools, source code management tools, and code merging. If you're part of the build process, you're looking at continuous integration tools and build status tools. If you are a tester or quality assurance / QA, then you're looking at continuous testing tools that provide quick and timely feedback on business risks. Packaging? Ding, ding, ding. Artifact repository, application deployment, staging. If you're part of the release process, change management, release approvals, release automation, configuration, infrastructure configuration specifically, and management, infrastructure as code tools. Monitoring process, applications performance monitoring, and end user experience. So let's walk through a very short example, simple example. Let's say you code a web to-do list app. Part of every boot camp development Udemy course you can purchase because it's pretty easy to do. So let's say that you have two developers, you have a front end and a back end developer, and they're both pushing code to a repo, GitHub, GitLab, Bitbucket, or Gitea. Check out my video on setting up your own self-hosted Git server using the open source Gitea platform. There'll be a link in the description down below. So after you merge to your master branch, because you always want to have different branches, you want to have a development, you want to have a staging, you want to have a master branch for production. So after you merge to your master branch, it triggers a deployment process where, let's just say, the first step is to do code analysis. You want to make sure that your code the quality is there, right? It works. Now let's say, for argument's sake, that you have a front end in React and you have a back end PHP. Why not? Right? So you do PHP unit tests. Once those unit tests successfully run, then you go to the next step, which would be a build. Could be a build step. Now, let's just, for shits and giggles, say that we're going to create a Docker image. We're going to have Apache in that Docker image, and we're going to toss our PHP code in there. Then we're going to have another Docker image where we're going to toss in our React with a Node.js server, and we're going to have a third Docker image with MySQL. So you have to build all of that. And let's say we use Jenkins to sort of trigger all of that and control that process and spin up a couple of machines to do whatever needs to be done there. So once the build is done, we want to deploy it. So we deploy it in our infrastructure, whether it's AWS or Microsoft Azure or Google Cloud or any other hosting company out there. Once we deploy it, then we want to run some tests. So initial tests, these can be manual, it can be automated. Initial test is, one, is it online? Does it work, right? Number two, the features that were just developed, do they work? And then, maybe three, we want to say, we want to have a set of tests that we run all the time to make sure that our entire application is functioning properly the way it should. Then on top of that, I want to do some benchmarking because these new features I think are going to get 1 million users, and I want to make sure that I can have 50,000 concurrent users at any given time. So I do some benchmarking on the systems that are running these Dockers. And then finally, we did some front end changes, so I want to run a Lightspeed test to make sure that I'm still within that 90 to 95%, or maybe I'm lucky and I get 100% rating with the Lightspeed, the Google Lightspeed performance test. So that is a lot. It seems like a lot. You can automate a lot in here. And yes, there are tools that can pretty much automate everything here, but there's still human interaction. So let's look at this from a slightly different angle. I break DevOps down, into 4 parts, right? Those 4 parts entail all of the pieces and essentially all of the tools, whether, you're talking about coding, whether you're talking about monitoring, whether you're talking about deployment. I break it down into collaboration, automation, reporting, and diagnostics. I call it CARD. So in the collaboration, you could have your front-end developer or your front-end and back-end developer talking with the systems administrator so that the front-end developer can say, I need a Node.js server and I need a specific amount of swap space because, of all of the builds that I'm going to run on a development environment or perhaps in the production environment, if that's how you're doing it. And then the backend dev says, I'm going to run. I've used this 1 million times. I have this old, this PHP API that I've created. It works great. I've worked out all the bugs and the kinks in it. I want to use that here. So I need Apache. And with Apache, I need the SSL module enabled. I want to have fail to ban to, try to block as many people who are just trying to bombard the server. I want to have, a bad bot blocker installed. And then, I want to run mine with SQLite instead of MySQL or Microsoft SQL or whatever, right? So that's a collaboration between those teams to set up the structure, set up the system so that the code will actually run on those in that environment. You also have collaboration in terms of the deployment, between development and the deployment. That really entails collaboration with those tools and with those teams. Then you have the automation aspect, which is what pieces and what parts can be automated and what pieces and parts should and could and should remain as a manual, reviews and verifications and certain testing. Maybe you don't have access to an API to run some kind of Lightspeed or some kind of SEO based reporting, so you have to do that manually. So then you have the reporting. On these processes that perhaps were automated, or the deployment process. Did the deployment, was it successful? Did it happen? If not, I get errors. Then I can start diagnosing those errors, and I can continue through that process. The thing is, that's all about working, I'll say, with the machine part. So when you dig a little deeper, then you see the human dependencies to that. We are not robots. At least, I hope most of you aren't robots or some kind of script that's pulling up my video for some reason. So the quality and the skill of the developers is extremely important. But so is the motivation, so is the energy, so is the focus. So if we go back to the definition of DevOps, the goal is to ship application service at the highest velocity, as fast as possible, with the highest quality. So CARD, as I call it, only helps so much. If your code is faulty, then the reporting and the diagnostics helps you catch a number of bugs, but you're slow and I'll say sloppy because you have to deploy more times to fix any bugs that weren't fixed before you deployed the first time. And oftentimes what happens is, you fix one bug and then you create another. So that's why the human part, or the human fault here is directly connected to the motivation, the energy, the focus, and also the skill. So, how can you improve? How do you integrate and improve? So let's start off with the designing the process. Either it's a new project or you're implementing DevOps tasks into an existing project. Design the process. You need to know what needs to be done, when, and how. Is it a bash script that triggers this deployment? Do you have a backup process in place? Does it happen on a merge request? What happens after process X? I don't know. Who needs to give approval? Not every project is the same. Some clients might say, you can't use GitHub because it's it's an online cloud-based system, and everybody, all I keep reading about is tokens being submitted in the Git. So you have to roll your own. Again, check out my video on how to get your own Git up and running using Gitia. It takes only 30 minutes. What if the project you're forced to use bare bones servers? When's the last time you went from installing an operating system from a DVD to setting it up on a bare bones server? Or better yet, when's the last time you set up a physical firewall instead of security groups in AWS or something through Azure? There are clients that still have that kind of they have top secret information that can't leave their infrastructure and blah blah blah, so all their servers are internally. You have to go to their office, go into their server room, install it on a bare bones metal. It still exists. So design the process. The second point is plan. You have your process designed, now plan it. Plan what happens when, and who needs to be involved. What happens if your sprint ends and your build manager is sick or on vacation? You should have a backup or a plan to postpone the deployment, and the client or your boss needs to be in the know. Bosses, clients, they hate surprises. Now we go on to automation. Automate more. Now I'm not saying automate everything, but you should automate what you can. Not everything makes sense, right? Some things you should keep a human advisor or a review. Just think about the CodeCove bash uploader tool hack, right? If you've not heard about it, then check out my video, because I did do a video about how it happened, why it's important, if you're affected, and how you can keep from this kind of thing happening to you. But with that automation, you want to make sure that the things you're automating aren't things that should at least have human review. And if they do need to have human review, you need to make sure that it's done. So now we go on to review and improve. This is not a set it and forget it game. You don't just set it up and then it's done. Things change. One day you're using React framework, and the next day your marketing department is screaming at you because maybe they read it's not SEO, it doesn't work, right? So you have to change the framework. Well, what does that mean to your process? Do you still need Node.js? What about your deployment process? Do you have to implement a new checksums for whatever new framework you have to implement for this project? So review and improve on a regular basis. There are new things that come out that you have to then add on to your process, and that's the improvement of it. Next, we're going to go into testing. So if you look at the carpentry industry, they say measure twice, cut once. Well, in our industry, it's really test 50 times and deploy once. For quality, right? For security. What ends up happening most times is deploy 50 times and test 50 times. There's nothing more maddening than a client finding a bug that you should have caught yourself. Again, I'll reference the CodeCove bash uploader tool. Within my video, that you'll see that's essentially exactly what happened. A client downloaded their software, did a checksum, a basic thing to do when you're using a third-party framework or application. He did a checksum. He saw that it was a mismatch, contacted the client. A couple days later, boom. They had to notify all their clients, including massive corporations like IBM. that the CodeCov bash uploader tool was hacked. Don't be that guy. So, basics. Don't ignore the basics. It's the little things that are going to get you in trouble. If you skip those little things and think, they're not important, those are the things that are going to come back and take a big bite out of your butt. And you might spend the rest of your life sitting on one cheek. So, be warned. The last point here, you'll see I have massive, bold, big as it could be, because to me, it's really where the human aspect can have a lot of control, and it's extremely important. Set realistic goals. A lot of times, we either agree to or we allow our bosses or our customers to just cram in a massive amount of work. And this is not just dev. This is for project managers. This is for product owners. It's for quality QA. It's for scrum masters, etc. If we cram too much, and again, like an 800-point sprint where the team is really only set up to do 100, your quality and your speed is going to suffer. And that negates the purpose of DevOps by definition. So, let's talk about people. You're only as strong as your weakest link. Your team can consist of people with extremely varying degrees of experience and know-how. No one person is judged by a success or failure of a project. It's the team that's judged. So it's important that the senior developers help and mentor the younger ones to ensure they get to the point where they're not Googling all day for answers, patching snippets of other people's code together, to make something that might work, but it's not qualitatively or security-wise correct. We want them writing their own stuff. It's in the standards formats defined with all the quality checks in place. Only then can we fire on all cylinders and reach the goal of the highest code quality in the shortest period of time. So, that's the team and the skills. Now it's your energy. I turn coffee into code, so get me some coffee. Now, the real point here is the team support, having each other's back. Let's say the deployment fails, and the deployment team still has other tasks to do, and they're super stressed. So I don't know, get them some coffee, get them some lunch, help them out. Maybe if you can, take over some of the tickets. Right, that sharing, that responsibility sharing is what's going to ensure that the project and the DevOps philosophy, the DevOps way of working really works. Their success is your success. Their failure is your failure. Now, I'm not saying that you need to go pick up the kids from school or go clean their house unless you have the means to do it. And if you do, you're more welcome to come over and help me do some work around the house. But I know firsthand CEOs that have gotten the lowliest employee coffee when they're under stress and working on a project. They buy pizza when the group is working late. It doesn't matter if it's for a hackathon where nobody's being paid or if it's for the biggest project for the company, because the CEOs know that the success of the team is the success of the CEO. So again, this is about the individual person, and this is really about you. I say get me in the zone, and I'll fix the source code of the planet. If I'm overworked because the sprint is jam-packed with that 800 story points and my team is only set up for 100, I know that, number one, I need coffee. Number two, I've been there many times. I feel for you, most important, is little chance that sprint or that code that's generated that is delivered in the quality that's anticipated based on the definition of what we're trying to do for DevOps. So the automation process we discussed can catch bugs, but there'll be a lot of them. There's no sense developing a feature in 2 days if you're going to spend the next 4 weeks fixing bugs. So for your mental and your physical health, make sure that you're open with your team about what you can accomplish and take care of your personal and mental health. So there you have it. We went through what DevOps is. It's a set of practices that relies heavily on tools, automation, collaboration between people to increase the speed at which we can ship services and software while maintaining the utmost quality. We spent time looking at the mechanical side of it as well as the human side of it. And we had some ideas how we can improve. I hope you learned just even just a little bit from this episode. If you enjoyed my video, please consider liking it and subscribing to my channel. I'll be creating and uploading a ton more dealing with DevOps, different tools used, tips and tricks, explanation videos, different IT topics, and of course, everything about the newest hacks that are happening out there, what they mean, how you might be affected, and what you could do to mitigate being affected. I really appreciate you spending the time with me, and I hope that you continue to join me on this journey. Thank you, and I'll see you on the next video. Take care.
Don't forget to ride. Farewell.